Hi guys, my name is Sagi Emmanuel. Welcome back to our second series. Of course, we are still working largely on how to find the equation of the tangent to a particular curve. I hope you have seen how I worked example 1 in the previous series, which is series 1. Please go watch that. If you haven't done that, don't forget to subscribe to the channel so that you can get more of the content as I upload in the channel. Well, I want us to read what we have here so that we can be able to solve the question in the autonomous sense. Please have a pen, have a calculator, and have a notebook to take notes in this series. Well, we are saying that let f and g be defined by the following, where f at x is given by 2x cubed minus 2x squared minus 2x plus 11, and g at x is given by 2x minus x squared. Well, we are saying to you, determine the value of values of x for which the tangent to f is what is parallel to the tangent of g. So one of the most important thing in mathematics is to note what you are given, or the new term that is mushroomed to the concept. Here we are saying that we are saying that the tangent to f is parallel to what? To the tangent of g. So by the way, we are saying that we have two tangents, the tangent to f and the tangent to g. So these two tangents are parallel. These are straight line, by the way, that are parallel. So when they are parallel, we are basically saying that they have the same gradient. They have what? The same gradient. So now I want us to be careful. Pay attention. I'm going to say, well, m represent the gradient. Now the gradient to f will be given by what? By f at what? F prime at x. And now the gradient to g will be given by that one. Remember that the derivative simply means what? The gradient of a particular point. This is what we know from the basic derivatives in calculus. So now I'm going to differentiate f and g respectively. So if I differentiate f, this will leave me with what? With 6x all squared minus a 4x and then minus a 2. And if I differentiate g at x, this will leave me with what? With 2 minus a 2x. All right. So we are saying that these two tangents, this is a tangent, by the way, 6x squared minus 4x minus 2 and 2 minus 2x. These are two tangents to the curve f and g respectively. So they have the same gradient. So these are gradient. So their gradient are equal. So I'm going to equate this gradient and solve it. Now I'm going to say, therefore, 6x squared minus a 4x minus 2, that must be equal to what? Must be equal to 2 minus a 2x. Because of what? The tangents are parallel to each other in there, so their gradient are equal. So the gradient of f is that one, the gradient of g is that one there. So it must equate them because of the concept parallel. There, they means they have the same gradient. Perfect. And then now you can see that now this is basically like equation which you have learned in algebra stuff. I'm just going to be very quick on that. So this would be 6x squared, and then let's see that we transpose that one. It will leave us with a negative 2x and what? A negative 4, and that is going to be equal to 0. You can see that the 2 is common right there, so you can divide or you can factor out the way you know how. I'm going to divide in this case so that I can reduce the polynomial. This will leave me with what? With 3x all squared minus x and minus a 2, that equals to 0. By the way, this looks like a familiar quadratic equation where one can factorize that. Of course, when you are good enough with that, the bonus when you get here, this becomes let's see that this is a 3x and this becomes x, and then the 2 should be here, and then the 1 should be that side, and this should be positive, and this should be negative. If you try and expand that, that must give you 3x squared minus x minus 2 equals to 0. So we know that this algebra, each factors must be equals to 0. So this will be 3x plus 2 must be equals to 0, or x minus 1, this must also be 0. So we now want to solve the value of x, which we are told determine the value of values of x. So there are two. In this case, we have x equals to minus 2/3, or x equals to a positive 1.